Let's look at this problem now. We're told that a mass of 1.3 kilo is connected to a spring with a force constant of 52 Newton meters. So I'll just quickly draw this. This is 1.3 kgs and this is 52 Newton per meter. If the mass is released with a speed of 0.28 meters per second, this is the V naught, at a distance of 8.1 centimeters, which is 8.1 divided by 100 meters, from the equilibrium position. So if this is the equilibrium position, this is the position at time t is equal to 0. And I'm assuming this is the positive direction, so this is also the velocity direction. So we know that x is equal to a times cosine of omega t plus phi, and v is equal to negative a omega sine of omega t plus phi. So substituting t is equal to 0, we get x naught is equal to a cosine of phi, and v naught is equal to negative a omega sine of phi. Okay, so the first question is, what is omega? So do that calculation here. Omega, we know that omega is under root of k divided by m, which in this case is 52 divided by 1.3. I will need to make that calculation because I don't have that value right now. 6.332. So significant figures are 2, so I'll just make it 6.3. Okay. This should be radians per second. Alright, so we know the value of omega, so I'll just substitute it in these two equations. So x naught is equal to 8.1 divided by 100 is equal to a is unknown and cosine of phi is unknown. So from this equation I can say that a is equal to 8.1 divided by 100 multiplied by 1 divided by cosine of phi. So that's one of my equations. The second equation is v naught is equal to negative a omega of sine phi 0.28 is equal to, I know that a is now this particular equation, so I'll take this a and substitute it here. That makes it 8.1 divided by 100 multiplied by 1 divided by cosine phi. Omega is right here. Substitute into this equation. 6.3 divided by sine of phi. simplifying this equation, I get 6.3 multiplied by tan of phi. Now this is because sine of phi divided by cosine of phi is equal to tan of phi. This is equal to 2.8. So moving around this equation, things around this equation, so I get everything in, I get tan theta on one side. I will multiply both sides by 100, and then I will divide both sides by negative 8.1 times 6.3. So what is this equal to? It's equal to 8 divided by 8.1 divided by 6.3. Negative 0.548. So phi is equal to tan inverse of negative 0.548. I'll quickly add a page after this. So phi is equal to, my bad, tan inverse of negative 0.548. It's negative 28.72. I think this is degrees, so I'll have to convert this into radians. Okay, multiplied by pi divided by 180. So I get negative 0.5 radians. Perfect. So I know the value of theta, and I can find the value of A using this equation. So it's 8.1 divided by 100 multiplied by 1 divided by cosine of phi, which cosine of negative 0.5 radians. So that will be equal to divided by cosine of the value I get is 0.092 meters. So once I know the value of amplitude and phi, I can write down the actual expression of x and v. So this is 6.3 times t minus 0.5 radians, and v is equal to negative 0.092 times 6.3 sine 6.3 t minus 0.5 radians. This is equal to 0.92 multiplied by 6.3, 0.5796 sine 6.3 t minus 0.5. So we have the equations for x and v. Now the question is, what is its speed when it is halfway to the equilibrium position? So the halfway to the equilibrium position, x1 is a by 2, so that is 0.092 divided by 2. I'll actually leave it just like that, which is equal to 0.092 cosine of 6.3 t, 0.5. Now that the only unknown here is t. 0.092, 0.092 get cancelled. So what I get is cosine inverse of half is equal to 6.3 t minus 0.5. So cosine inverse of half is so 1.047. So we just solve this equation to find the value of t by 6.3, and t is 2. Oh, my bad. It's 0.2455 second. And the value of v1, now that we know t, question is what is its speed. So v1 is equal to negative 0.5796 sine 6.3 times 0.2455 minus 0.5. So solving this, alright, so sine of 6.3 multiplied by 0.2455 minus 0.5, this multiplied by negative 0.5796. So the value I get is negative 0.5, but because we are asked to find the speed, we will find the absolute value and there won't be any direction. So meters per second. Looking at the significant figures, this is our answer. Perfect. Next question. So a simple pendulum, we know the length, it makes 5 complete swings. So for a pendulum, a complete swing is going up to the amplitude, coming back, going to the negative amplitude, and then coming back. So that's one complete swing. That happens within time t, which is the time period of a pendulum. In this case, 5 times t is equal to 37 seconds. So t is equal to 37 by 5. So 7.4 seconds. Now we know that for a pendulum, the time period is equal to under root of let me check my equation so I don't make a mistake. Yes, it is 2 pi by under root of L divided by G. So just substituting all these values, 2 pi, L is 2.3. Now we are asked to find the acceleration due to gravity. So we cannot say G is equal to 9.81. This is not right because we don't know the acceleration due to gravity. Alright, squaring both sides. And moving G to the other side. And moving 7.4 squared to the other side. Alright, we need to now calculate this. Squared multiplied by 2.3, and the value of G is 1.658. Now, just as an exercise, let's see what the time period would have been if G was equal to 9.81. So time period would have been 2 pi L over G. L is 2.3 meters and G is 9.81. So it would have been 9.81, taking the square root of the answer and multiplying by 2 pi. So the time, this particular pendulum on Earth's gravity would have had a time period of 3.04 seconds, which is half that of this particular pendulum's time period. So yeah, that's the answer.